So the 10 damage every time, no matter how I trigger it, that's the Unreal Engine gameplay ability system is actually working. So the attributes, a damage calculation, and a delegate chain all deriving one clumped health number. And in this video, we'll be laying a foundation on everything else in this project's combat is built on. Let's go and build it from zero. So in this video, we'll be covering the turning GS system on and getting the foundation working for it. To enable the gameplay ability plugin in the Unreal Engine project, we need to add the modules into the build.cs and as a dependency list. You can see over here in this list we have included the gameplay abilities, gameplay tags, and gameplay task. It compiles nothing. It's just the thing that I'm adding the GS abilities and the GS code available for the project, the engine codes. So every actor that can take damage needs an attribute set. An attribute set is a Unreal Engine object, and it basically holds the numeric stats. So over here, this hologate attribute set is a shared base both for hero and enemies. So the hero and enemy, they can inherit their attribute from this particular attribute hologate attribute set parent file. So basically what's this hologate attribute set is holding the health, max health, and the defense. So each attribute follows the same boilerplate pattern that GS expects. So these macros expands into the get health, set health, and init health, and there is also a getter for getting the attribute sets itself. So it's a standard GIS scaffolding. We are handling it once as a macro rather than writing it over and over for every attribute. So basically to keep it consistent. As you can see over here, these three attributes here are actually replicating using their corresponding functions, which I have defined here. So the health is replicated using the onRep health. The max health is replicated using onRep max health, and this defense attribute is also replicated using the onRep defense. But there is another attribute which called the incoming damage. So basically what is this incoming damage? So the incoming damage is a meta attribute, and I deliberately not replicated it because it only exists for like one frame. A gameplay effect writes a damage number into it, and the post gameplay effects executes. Okay, so what is post gameplay effect execute? It's a function. So if I go on top here, you can see this inherit function that I have overridden in CPP file here. So what basically it does is it's basically a function which GS calls it automatically whenever any attribute in this attribute set changes. It needs to consume it immediately. That's why. So if I now go into our CPP file here, so this chunk of code, what's it's doing up here? So basically It's reading the incoming damage and resets it to zero in the same frame, so it's never linger as a real state. So also you can see in this function what we are doing, we are checking if the damage done is valid. So if it's valid damage done, then we are subtracting the health and also clumping it. There is another functionalities which we're using is the broadcasting health change. So when it fires, really firing two of my own delegates, it's that I've already declared here in the header file. So you can see this is the on health change and on out health. On health change and on out health change. This pair ends up driving basically everything downstream in the project. So from hit reaction to death, the hood, the floating health bar. So basically one clump, two delegates, and entire rest of the combat UI is just the listener instead of polling. So moving on to our hero attribute set .cpp and enemy attribute set .cpp. So both the class is inheriting from the hologate attribute set, which is the parent shared class. So our hero attribute set is basically what it's doing here. It's adding the stamina and the max stamina on top of the shared base class, and the enemy attribute set is adding attack speed and the movement speed for the future montage plays. And as you know, both are inheriting everything from the hologate attribute set. Now we'll be moving forward to our hologate player state.cpp file. So it's basically this class, parent class, is a player state class, and basically a player state is replicated. This basically it's a replicated actor that stores a public and persistent data about a player, like our hero character here. So the inside here you can see I have defined the ability system component here. So this ability system components exist because pawn are disposable, but who is the player and what they have, that shouldn't be, right? So that's why, like, I want this game to have the add the ability or add the functionalities of multiplayer later. As of now it's a single player, but I somehow want this game to be having a multiplayer ability. So basically for the future purpose, if I want to go ahead and make this particular game as a multiplayer, so the thing is that so when a client A is playing, the other client, like client B or client C, they need to know like what is the player state without touching the player A's private player controller or private data, right? So basically this is a public state which is available for all the clients. So that's why we need this ability system component, and which enables us to record the public state for the other clients. So here's the design decision that I need to make, what matters the most. Where does the ability ASC, means the ability system component, lives? It lives under this hollow player gate.cpp class rather than in the character class, because if I ever wanted to add any respawning to the hero character ability, and the cooldowns should survive it too, right? So that means our AC needs 2 entry point, because player stat replicates on its own schedule, and it's separate from the possessor. Okay, so let me go into the hero character.cpp class here in order to check the implementation for um, ability system. So basically, these are the two functions. One is possess spy and other is on player stat. So basically, both this function is calling the same init ability actor info, and that's a standard player stat owned AC pattern in GIS. Uh, Enemies are the opposite here. So if I go to enemy base.cpp here, so I mean, their enemy's AC lives directly on the pawn enemy base class and initialized in the begin play, as you can see up here. It's getting initialized here. So basically the idea behind it, the zombies or the other enemy character don't need to have a player stat, and it doesn't needs to survive the death, right? Because when the enemy's pawn dies, the AC should die as well. So I mean, that's the way it is. So now I wanted to move to another important class here, which is hologate gameplay tag class, and this is a cpp file, and this class is a plain C++ class, and it doesn't have any parent class, unlike the other classes here. So the gameplay tags on a gameplay ability are how the abilities talk to each other or talk to the game state, right? So if I wanted to see the actual implementation of the tags, I should go to hologate gameplay ability.cpp file here. So basically what we are seeing here in the constructor, we're using this activation block tags dot add tag, and we're tagging the state.date. So basically what we are saying here, so it's getting that particular state.date is get tagged and get activated when hero dies. One more reason why do I have this tag class up here, because I wanted to declare this once in C++ instead of scattering string literals in blueprint classes, because I don't I actually because I wanted the later abilities and the effects and the animation notification references the exact same tag checked at compile time. All right, so let's move forward to our damage pipeline. So the basic questions can come: why do we need a damage pipeline? So basically, without damage pipeline, every attack type, like whether it could be a melee attack, gun attack, or future weapon attack, so every type would need its copy pasted subtract HP logic that can differ, that can drifts out of the sync and ignores things like the defense or buffs. So routing everything through one shared parent class, that would help to keep the formula of the damage consistent for everyone. Okay, so let's move on to the actual implementation of our damage pipeline. So if I go into the gun projectile.cpp file here, you can see basically when in the gameplay a projectile hits an actor, it applies a gameplay effect that carries a per attack bonus. And that being said by set via color magnitude up here. So when it got set, and then with this in the exact calculation damage.cpp file, this functionalities here is the execute implementation. So this particular function here is actually responsible to run the formula, reading the source attack and the target defense, adding the bonus and writing the result, and then writing the result into a meta attribute rather than touching the health directly. So you can see here. So this bonus damage is getting set by this particular function here. So after this happens, in the gameplay, in the hologate attribute set, we have discussed earlier this particular post game effect execute function, and this particular function is actually receives the incoming damage, and that particular change is getting applied to our attribute set. So you can see we're setting and clumping our health change if we have the valid damage, and then we are broadcasting the health change, and while broadcasting it, if the health is less than 0, we are calling this delegate on out of health, and then we are setting that player or setting that actor die in our gameplay. Okay, so there is a missing piece here. I forget to mention in the exact calculation damage.cpu file. So there's a line up here. So after setting up the bonus damage, it's trying to check whether the damage done is valid or not, and then execute this thing. So what is this line is saying here? So let me explain this thing to you guys. So basically what happens here is it's an basically execute a calculation, and in such way that it's saying that here's the attribute change, and here's the math operation, and here's the number. So it doesn't touch the character's health or character stat directly. It just queues up ups the a particular instruction to for later, so for the later that a GAS can use. So basically the whole line means add damage done to the target incoming damage attribute, and it's not touching the health directly. Okay, so that is what it is. So this is the end of this video. If GS has been intimidating you, hopefully this show you is just an attributes, effects, and delegates. Once you break it down, the next one is linked here. So see you in the next year.